Hello everyone. I hope that your morning, afternoon, or evening is going well, and appreciate you taking time to attend our session titled xGenerative Design and the 3D Experience Platform. My name is Gerard Elsini, and I'll be co-presenting with two of my esteemed colleagues, Chris DeVries and Rohit Bhardwaj, in an information-packed and exciting session. We'll kick it off with an intro of the 3D Experience Platform, then show a digital workflow example using a coffee machine project and all its stakeholders, then on to an overview of roles and apps to increase your knowledge as we introduce xGenerative design, or xGen as we sometimes call it, where we'll take a quick glance at how generative patterns are used in different industries, and finally our attention focuses on automotive trends, showing several use cases for both interior and exterior patterns and textures using xGen to help you achieve some truly amazing designs. And to wrap it up, we'll be happy to take questions from you. So let's get started. Our focus is on xGenerative design, a patterning application that is included in a cloud-based role called 3D Shape Designer. But before diving straight in, it's important to illustrate how patterning fits into a larger context of creative design within the 3D Experience Platform. So what is the 3D Experience Platform? It's a mixed cloud-based and desktop solution portfolio allowing you to safely and securely create, store, and manage your product design, simulation, and manufacturing data throughout the entire product development process, all in a single, flexible, connected ecosystem. It allows you to work in a manner that benefits you the most, and this is possible based on roles and applications. Let's compare studio processes. With a simplified traditional design studio process, you can see that there is a siloed approach, starting with an input coming from advanced design that studio artists use to base their themes, which are then referenced to create Class A surfaces. And when completed, the surfaces can then be shared with the pattern expert who has been waiting all along to build on top. So as you can see, these silos make it a time-consuming task to share data, and when data is finally ready to be shared downstream, it's usually obsolete. This often causes compromises to the original design intent because of last-minute changes to satisfy downstream requirements. To the right, we're showcasing the value of a collaborative digital thread on the 3D Experience Platform for all stakeholders, including the design manager, his team of experts, and the collaboration of all the disciplines of his studio without interfaces. What I mean by saying without interfaces is that our competitors have many disconnected solutions glued together with an interface designed to appear connected, which is not truly the case. So here you have a collaborative digital thread where all stakeholders can access the same data, engineering can change and update reference or envelope data that is used to govern the design, and modelers can provide solutions in real time as changes are being proposed in the reference data. And in regards to visualization, CATIA has a world-class solution that requires minimal preparation, so going into a design review is not time-consuming or stressing, and it uses current data. Each design profile has its own package of roles which provide all the apps or tools needed to accomplish their tasks. The creative designer has a mix of creative-centric apps, the Class A expert has a mix of surfacing-centric apps, and the experienced designer has a suite of apps suited for design reviews. And all the other profiles you see here, like the simulation expert, the marketing render expert, and of course the pattern expert, are all working on the same platform with their own tools, all accessing the same data from the 3D Experience Platform. Here's an example using a coffee machine scenario. So you have an engineer who is generating the packaging data, and the creative designer who is bringing this data into his session. As mentioned earlier, this is the same data that he can use in his own assembly, not a copy, and he can do this while the engineer is continually working on his own data. The designer does not have to wait until it is complete. He simply references the data, and if the engineer makes an update, he instantly has the revised data, so this is real collaboration. It's easy to import a 2D drawing, and there's also a solution to sketch in 2D or 3D over existing geometry, basically to ideate on a design or maybe to get an understanding of volumes. Of course, it's up to you. Some may opt to go straight into modeling, as you can see here with CATIA Imagine and Shape subdivision surfacing, and quickly coming up with the initial design. And at any given time during the process, a manager or any other stakeholder who may want to give feedback can log into the platform and review the model at its very latest state. There's no need to be CATIA specialists to access and review the data. It can be done on any device via a browser through a very simple to use tool that enables section cutting, exploding, and even annotation. So now you see the creative designer modifying the design based on the manager's input, but it creates an interference condition with the engineering data. The engineer, who is referencing the styling surface, can clearly see the interface and update his geometry, remediating the issue. And of course, this could be vice versa, where the engineer makes an update and the styling surface needs to accommodate. So here, the creative designer continues to model some details with a combination of Imagine and Shape and Generative Shape design. Color, textures, and materials can be added to your model at any time during the design process, with very high-end real-time visualization and a world-class rendering tool, all integrated inside CATIA. And then at any time, with just a click of a button, it's easy to review your data in VR if you have an HMD connected to your machine. And the Class A expert can get a head start with the surface refinement and production release surfacing using CATIA ISM. There's no need to wait, as he also references the creative designer's part. And now we see the pattern specialists, who can reference a surface from the Class A expert or creative designer to build a pattern. It's node-based and very similar to competitive solutions, where you connect those nodes together in order to generate your pattern. Then at some point you publish it and save it. And then the creative designer can hit the global refresh button and instantly see the pattern applied to his design. We have an application called Human Design where the product can be experienced from a first-person perspective, much like your real customer will experience. Human Design is a great tool to put your design in a human context in many ways. And for simulation, we brought tools from our standalone solutions like Abacus to the 3D Experience platform, so our simulation expert has full access to the model and can run his simulations in parallel to the design process. Then give instant feedback to the design engineer. So you can see this team of experts are working in parallel on the same model and are much faster than the traditional approach. And as mentioned earlier, we have a high-end real-time and full ray tracing solution to render out your image in high quality for reviews or marketing purposes with physically correct behavior of lights and shadows. And for reviewing the model, we offer an application called Product Perception Experience that directly references the continually evolving CATIA data, so if any of the surfaces were to change, you would instantly have access to this data. This application offers a simple visual interface for authoring and presentations, specifically made to compare variants, design alternatives, and illustrating the product experience. It's all about making design decisions visually. So here we're selecting a variant of a script to this very complex pattern, but it can also be a variant of the same model to review and discuss different shapes. The main purpose of this example is to help you understand the unique collaboration between all stakeholders of a project using the 3D Experience platform and its huge benefits to your team. So here you see all the coffee machine project team member applications mapped to their profiles using rows that we mentioned earlier. And with those rows, the user has access to different applications shown on the left, which give access to the features on the bottom. The model in the viewport always stays. Designers can switch between modeling, visualization, and VR applications in a single click. And as mentioned at the beginning of this presentation, the 3D Experience platform is a mix of cloud-based and desktop applications. So the native client is your local installation that you may know, such as CATIA v5, Alias, or Rhino. But there's also a large part that is based on a browser where there is no installation necessary. From both the native client and the browser, you have access to the same data. So for example, we have 2 roles chosen. The Industrial Designer, which has Human Design, Generative Shape, Live Rendering, Natural Sketch, Imagine a Shape, and Part Design. These are all available in the native client in the locally installed part of the platform, as well as VR Reviews, which comes in a separate role. But now we also have applications where you can generate 3D data working from a browser, so there's no need for local installations for these applications. There are 3 available: X-Shape Design, which is similar to the Imagine and Shape subdivision modeling; X3D Design, which is similar to Part Design and Generative Shape Design; some review tools where you do not have to be a CATIA expert, so these are ideal for a manager who wants to see a status of a model or maybe a review of the 3D model. And the focus of our session, xGenerative Design, which is also available in the 3D Shape Designer role. A role created with 3 main objectives. The first, enable creative design, with the best combination for designers to boost creativity, with autonomy all along their industrial design workflow, including virtual clay modeling to perform freeform shape exploration. The second, work anywhere on any device with web apps, based on a cloud approach to retrieve data from anywhere, using 3 web browser apps to work on any device, with no installation required and always up to date. And third, for 3D design, freeform shape sculpting, and pattern design, you have freedom with the interoperability between web and CATIA native apps, which are fully compatible thanks to the common database, using the same technology that makes data fully editable. With this solution, we address creative designers that need to be nomad while working. We want to allow them to work on their favorite device, no matter if they're at work, at home, or traveling. They can seize inspiration on the fly. They can be freelancers, design agencies, or even integrated studios. The 3D Experience platform seamlessly connects studios or small agencies, and designers can experience smooth and efficient workflows with our web-compliant user experience. Here's a quick overview of the 3 complementary applications that compose the web-based roles: X3D Design, X-Shape Design, and xGenerative Design. This package provides to designers capabilities to design any kind of product from any device. So here we can see a mapping of the applications in the 3D Shape Designer role. CATIA X3D Design maps closely to GSD and Part Design. CATIA X-Shape Design is close to Imagine and Shape. And finally, the xGenerative Design Patterning solution, which is strictly cloud-based today with no native client application equivalent. But on that note, stay tuned in the next coming week or 2 as there will be interesting news on this topic. On to the focus of this presentation, xGenerative Design. So, what is it? CATIA xGenerative Design is a newer technology to design, explore, and validate variants of complex, repetitive, and non-regular shapes using an intuitive algorithmic approach, and as you just learned, is part of a new range of CATIA web browser-based X applications available on the CATIA cloud, allowing users to create procedural, organic patterns and shapes. Here are some core values of XGen. It is interactive and 3D-centric. It facilitates creation of simple to complex shapes and patterns intuitively and interactively. It allows exploration of styling ideas natively during the design process, and it's flexible. The spirit of XGen is to be available anytime, anywhere, and on any device, because everything is computed on a server, which means you can work from whatever computer you want at any given point of your work in progress. This application totally addresses what Grasshopper is offering and much more: program modeling with a graph and the ability to model in 3D. It's a very easy, intuitive UI for building the graph. Someone who knows Grasshopper will learn it in just a few minutes. Anyone who's used it will tell you how addicting it is. I'm a novice with limited experience and can certainly attest to that statement. As you gain experience, it really provokes your mind to explore unimaginable ideas, and I have quite a few swirling around in my head already and can't wait to dig deeper. All the tools to manage the items of a pattern are here, so where you take it is limited only to the imagination. Very important to note, a huge differentiator is that this is a CATIA model that can be reused and applied to different ideas. Tools like Grasshopper do not offer that capability. So here we can change the diffusion ratio, UV swap sides of the fade, etc. Among the hundreds of patterning functions, XGen features some major differentiators, like the multi-mode design experience, which allows the users to model patterns in the powerful CATIA 3D environment, in the graph editor, or both simultaneously. Work split screen, on dual monitors, or even overlay the 3D viewport in the same window. This is a recent improvement, by the way. There's also an option to change the background opacity. So this way you can work more efficiently if you have maybe a single screen or are working on a mobile device. And this mode can be turned on or off with a mouse click or a shortcut. You can also close or reopen the graph editor using a shortcut. Another very interesting feature is the ability to create a single packaged user operator comprising hidden multiple graph operations. To create one, select all the operators to be packaged. Then in the pop-up menu, there's an option to create a new operator. Then give it a name. And you can even assign an image for the icon. Configure the inputs and outputs. And then save to a library that is stored inside of a collaborative space. The idea is that a pattern expert can create these complex patterns to be used for different shapes, or maybe even a more casual user to apply on their own design. To instantiate the packaged operator, it's just like any others. You locate by search or in the category that it was assigned. Then it's just a matter of designating the inputs, like the chair design on the left side. And as you can see, the user is adjusting things like the color output and panel thickness. And just like that, you're able to share or reuse custom operators. Patterns are prolific across all industries. We spotlighted a couple here. In the A&D industry, you see complex patterns applied overhead, on passenger seats, and even the exterior of an aircraft. Here are some examples coming from my colleague Felix Rokel, this one for aircraft tray tables, and reviewing an alternative pattern. Patterns are widely used in architecture for things like high-rises, museums, and bridges. And in T&M, XGen is perfectly suited to generate those irregular patterns that you see trending in the automotive space these days. Like this cool concept car that Felix designed using CATIA Imagine and Shape, with some patterns applied to the roof, hood, and front grille area, and rendered out using physically based rendering materials with emissive lighting. These are examples coming from a concept car with many different patterns generated from XGen used to come up with a perfect theme. We'll talk a little more about this later. Taking a look at automotive industry trends, they include very complex front grilles, textured panels, seats with patterns, speaker grilles, and on and on. An emerging trend is panoramic glass roofs that are providing a unique customer experience. But unfortunately, due to a greenhouse effect, it's not always a good one. So some automakers are taking the initiative where occupants can instantly vary the tint of their glass to help keep out harsh sunlight and blocking heat while in its maximum tinted state. Below are some examples of variable opacity roofs using suspended particle device technology. And this is an opportunity to get creative. To the left, BMW shows an elegant free-flowing pattern on a concept car. And on the right side, the Cadillac Celestiq, hitting production in 2023, boasts a modern grid type of pattern. Glass roofs may eventually double as transparent OLED displays where a wide array of bespoke patterns can be displayed. XGen is well positioned as a perfect solution for these existing and emerging trends. Now let's move on to some use cases. Taking a look at this dash panel through the windshield, let's see how it came to life. Starting with a natural sketch conceptual drawing of living speakers and a design brief within the project stakeholder community. The dash panel above shows sketched out features defined where an adaptive pattern goes. The request is to have hexagons open when there is music and closed when there's not. And below are some inspirational images to help define the idea. So in the locally installed CATIA native client, the modeler chooses the pattern support surfaces of this dash panel, and with these surfaces, the pattern expert can go to work. Here the first thing is creating a thick surface, then defining the bounding area, extracting the corner vertices. This is done to calculate the length and width distance, defining the grid size. And from there we can generate polygons, specifying the number of sides, so 6 for a hexagon. Then doing offsets and projections to the top and bottom of the thick surface, creating blends between them. And all along the way you can trap operations and hide them to reduce clutter on the screen. And with user-defined controllers, play around with the parameters such as the hexagon size and the speaker opening at various angles to reflect the audio volume change. This is the dash panel rendered out with materials assigned. And on the other side, you can see the evolution of the pattern depth throughout the feature. Now let's take a fly through the cabin interior, starting with the painted frit on the windshield as we fly inside. You can see a whole pattern applied to an overhead center console. Again, the non-uniform 3D hex pattern on the dash panel we just talked about. A pattern on the steering wheel, and a time-lapse of the dash panel workflow. XGen is also used to create the knurling on this center console gearshift knob. And here's a time-lapse of that workflow. And finally, a design exploration taking place on a tablet. Here's a nice rendering spotlighting the gearshift knob. And just a few words on the project mentioned earlier called A Portrait of DB in tribute to David Bowie. This was done to push the limits by creating a pattern on the car's surface that's driven by the music. So here you can see an extrude surface made off a frequency image of the music itself, and to create the surface pattern which can then be intersected with the model to create a character line. And from here to complete the definition of the pattern. Then we can vary the shape by playing with some parameters. And finally, we can review different stages, patterns, and viewpoints in the product perception experience. Let's talk about front grilles, which are not just an essential functional component, but a centerpiece from a design point of view, because it's an expression of the car's face and brand identity. But they're complex, taking time to create, and are seldom used in the ideation phase. That can change. So we have a couple different themes. My manager, Chris DeVries, will walk you through the first one, which is a honeycomb pattern. Chris, it's all yours.
Thanks, Gerard. I'm going to show you a quick example of how to build something in xGenerative. So the example I've built out is this hexagon grille pattern. And I think this is a good example because it's relatively simple, yet shows the principles of how things are connected and what the logic is of building an xGenerative model. Now the goal here is to build this cool hexagon pattern on the surface of the front of the e-car with this overlapping sawtooth bite on each of these hexagons. Now I've already built the model, and so what you're seeing here is the completed model with a bunch of features hidden, and I'm going to build it up step by step to show you sort of how it works. The only thing you see here is the resulting surface that we're going to map it to. But we're going to build this in 2D and map it at the end. So the starting point is this feature called Hex Grid, and it creates a grid of points. You have options of different kinds of grids, and you have different parameters that you feed it. So for example, this hex grid is sitting on the XY plane. It's got a cell spacing of 15 millimeters, and it's a 3x3 grid of points. And the feature on the right-hand side is the 3D representation of it. And on the left-hand side, you see that same feature in the graph view. Now, this hex grid has been connected to several input parameters that I've split out. So num_x, num_y, and cell spacing are all parameters that I've decided to separate and now I can play with independently, right? So if I, instead of a 3x3 grid, want a 5x5 grid, I update those parameters, and you'll notice the 3D on the right-hand side recalculates. Now, this is powerful. As you start to feed features from one to the other, you can set up long chains of updates. So for example, this next feature I'm going to turn on is a polygon sitting on top of each point. So it's also sitting on the XY plane. It's 6-sided polygons. We can show the point. I'll put pentagons on top of each point. Switch it back here to hexagons because that makes more sense. But each of these inputs is fed either a static value or from something else. So for example, the result of this first hex grid point object is a 5x5 array of 25 items. And I feed that into this polygon object. And naturally what you get in, if you feed it 25 points, is 25 polygons. And this is super powerful as we start to build out this chain of items. So for example, if we extrude those polygons vertically, you'll get a 5x5 grid of 25 extrusion hexagons. And as you change the parameters, everything updates. So here I've set it back down to 3x3. If I wanted to set it to 9x9, you would update and you'd see, a massive amount of geometry be created very quickly just by changing the parameters that you're feeding into it. Now, as we start to build out the geometry to do this, we need to turn these surfaces into real physical volumes. So, we can thicken the surfaces that I've created, and I'm feeding it another parameter of wall thickness. And by dividing that wall thickness in two and feeding it into each direction of thickening of that surface, I'm able to center my volume on that surface. And this is pretty cool. So as I adjust, for example, the wall thickness parameter from 3 millimeters to 5 millimeters, it grows from each direction. Now, so very quickly, I've been able to create a hexagon pattern and given it some thickness. What I'm going to do now is I'm going to hide these features again, because what we need to do next is create the cutting plane that we're going to cut them with. And so I've got this separate group of features down here, and this is an organizational trick that you can use. You can create these sort of subgroups of features called create split plane. And we're going to start with creating an array of planes on top of each of these points, offsetting another plane off of those points, putting a point on that offset plane, creating a rotation axis around that point on that plane, and then finally rotating that axis, or rotating that last plane around that axis that I created. And so I now have a looks like 3x3, 9 separate planes, each rotated around this sort of cutting angle, ready to cut those hexagons that we created earlier. So here, I've got the geometry I'm ready to cut, and now I'm going to take the result. So this thickness that I've created, and the plane that I've got created ready to cut, and I'm going to split the two features from each other. So you'll see the cutting planes that just got added. I'm going to get rid of the original thick, and you'll see, wow, look at that. It's started to come to shape. Now from here, I've basically got the geometry that I'm ready to morph onto the final surface. There's one final thing we need to do, which is the command to wrap this geometry to the ultimate surface that I need needs a reference, basically, a reference and a target of that wrap command. I won't go through each step, but basically, I'm creating a surface that sits underneath of this repeating pattern. And the basic methodology here is we create a bounding box, and we silhouette that bounding box onto the XY plane, and then we create a surface out of that. And from there, we've got our target surface, we've got a reference surface. We can wrap this geometry onto the destination. And wow, that's pretty cool. The powerful thing is it takes a specialized skill set to be able to create one of these. But once you've identified the parameters that you want to pass on to anyone in your organization, you can identify those as inputs. And there's an experiment tab here where you can feed this to anybody else. So, if I was a designer looking to design a grill based on this hex pattern, I could be passed these inputs, and I can adjust and play with all the parameters until I come up with a design that I'm interested in. So let's go redefine a much denser hexagon pattern. And in the background, what CATIA xGenerative is doing is it's creating an enormous amount of geometry in this 11 by 11 repeating pattern. And it's going to create the scaled target surface and scaled reference surface to be able to create this really cool pattern. There's a lot more depth that we can go into. What I showed you is a very basic example, but I hope you understood a little bit of how xGenerative design works.
Thanks, Chris. That was really good. And while Chris was working on the honeycomb, I was thinking about another idea inspired by a similar design that my paisano and newly retired colleague Pierluigi Bertolotti created. This grill has concentric circles and radial lines projected onto a support surface. But unlike the honeycomb grill where the pattern is mapped, this one builds the geometry directly off the support. I'm not going to go through the details, but want to spotlight the ease of inserting operations that enable some cool variants that might not have been initially planned out. I'm going to insert an operation to scale the spherical surfaces at the grill intersection points. So here I'm inserting an affinity operator and connecting it with the sphere output. The center point is the same as the spheres. We plug in an axis direction and a plane to orientate the scaling. And then I can open the operator and either input a static value or pull out the integer dialog box. So here I'm bumping the value to 2 and watch the geometry rebuild. Next, I publish the output and expose the parameters to carry them across to the native client. They're also accessible in the Experiment tab where I can let loose and just kind of play around with the different combinations. So after saving my work, the model is opened inside of the CATIA native client where a global refresh is performed to update the part. Applying materials is easy too, so here I'm using an eyedropper to pick and apply the polished metal coming from the emblem bezel. And this emblem size is tied to a sketch. So if I were to change the diameter of the circle, the emblem will update along with it. And this sketch circle is also referenced by the circular grill pattern. So here I'm returning to XGen to refresh that model. Then I tweak a couple of parameters to change the circular grill spacing from the emblem. Save. Then refresh my native client side. This is true digital thread collaboration. Let's take a look at quad grids with gradation on this roof panel. So here I applied a quad gradation pattern to a hidden roof surface. As I scroll through the graph, I'm turning on controllers of inputs, making them available in the Experiment tab, and allowing me quick access while working inside of XGen, and again, exposing them as published parameters when the model is open inside our native CATIA client. So this is the Experiment tab with the activated controllers. Here I can play around and get different results. The first is the position of an attractor line. Looking to the lower right corner is our attractor line and pattern. As I modify its position, note the pattern influence change relative to the line. I took that pattern and mapped it to our roof surface to the left. Next, I changed the influencer length, which is basically the strength of influence over a given distance. And the number of rectangles in X and Y can be changed. but notice how the shape has turned oblong. This is because there's a mapping process taking place. So if you want to keep them consistent, then both X and Y values need to be the same. Now you can see the roof assembly as we open the part into the CATIA native client. And let's see how two different users can collaborate on this design. To the left, our pattern specialist makes a change and saves the part. On the right side, our designer receives notification that a part in the assembly has changed, so a global refresh is performed, synchronizing the data. As mentioned earlier, parameters created in XGen can be published and reused inside of the native client. You can see them listed in the tree. So now we're making a change to the influence line position and watching the pattern rebuild. Same thing with the attractor influence length. And then we take a look at the roof within its entire context. Now let's take a look at some ray traced images that my colleague Charisse Caldwell created using CATIA Live Rendering. This is the Sport Honeycomb Grille. Here's that same grille under different lighting conditions and a polished metal finish. This is the circular or spiderweb looking grille in black. And again with a polished metal material applied. Some shots of the panoramic roof with the suspended particle device pattern applied. And an ISO shot that shows off the car paint flakes in clear coat finish. xGenerative design can also leverage the same 3D knowledge language that powers CATIA KnowledgeWare. So for that, I'm going to hand it off to Rohit Bhardwaj, who can tell you more.
Thanks, Gerard. Okay, so let's jump right into the topic of scripting in xGenerative design. XGen can leverage the same EKL language that powers CATIA KnowledgeWare. So those of you who don't know, EKL is enterprise knowledge language. It's pretty close to JavaScript. So for advanced users who really want to push the limits of the product, for example, if they may want to create loops or decisions inside those patterns, we can embed these EKL scripts into the logic network, and that really extends the functionality of patterns and the design decision it makes. The script editor, which comes with XGen, it has a dedicated guided interface and documentation, which is integrated into the scripting editor. So this is the example that I'll try to cover quickly. What we'll do is we'll use a couple of points on the surface and try to create a branching pattern originating from these two root points. Let's quickly have a look at an example here. What we have is a dome-shaped surface, and we'll create a couple of points on this surface, right, using point on surface command, and they'll be our root points. The next thing what we'll do is we'll populate a bunch of points, random points on this surface, and let's make them 100, right? And just for better visualization, we can add a couple of spheres so we can easily recognize the root points. Okay. What we can now do is we can start adding EKL script. So this is how a script editor looks like. It comes with a help browser. You can see examples of each and every type. We can even click and try those examples in the browser. Let's start building the logic quickly. So this is a place where we declare the inputs and the output nodes of the script. We can declare the root points as a list. We can declare the sample points as another list. The minimum distance that we want as a length variable, and then the branches as an output list. Let me paste a script here. What we are doing here is trying to find the closest neighbors for each root points. To find the nearest points, we are using the near collection function. Right? We are setting up the closest points to all the list of points that we assign. from the sample points. The next step is we can start adding branches in between these lists of points. Here we can, you can see CGM line between the first point and the second list. So we can create such logics with EKL in XGen. Now we can try and play with this script here. We can connect it to different parameters with the points, inputs, and the step starts calculating. We can now start playing with different values and parameters to see if we like the pattern, if it's too busy, if it's fine. What we can now do is we can start adding more polylines to the script. The aim is to create a polyline linking all the points to their origin passing point. Right. So we can have and build such patterns inside EKL. Here you can see that I'm now connecting the polylines to the origin points with their nearest distance value. So we can keep playing with these parameters until we are happy with the pattern that we just made. Okay, so here you see that we're playing with different parameters and the scripts get updated to a new pattern using just number of points, minimum distances, and things like that. So we can now save these patterns and reuse them again in our future design. Okay, so here you see that we are giving it a completely different surface and completely different root points, and the script recalculates the pattern on a new geometry. So we just saw how EKL really extends the functionality of patterns. It's quite intuitive once you start doing it. It just looks a little daunting in the beginning, but it's really, really powerful. Okay, Gerard, back to you.
Thanks a lot, Rohit. You just saw some powerful scripting EKL capabilities, 3D modeling and patterning solutions, and world-class visualization. But what about a sophisticated tool for decision makers that can explore different design alternatives and color and trim variants? For this, I asked Charisse to create a review using CATIA Product Perception Experience. It's a simple visual interface made for authoring and presentations. This application is specifically made to compare product variants and design alternatives. It's all about making design decisions visually. It works on a desktop, touchscreen, Powerwall, and VR. But what is really important to remember, there is minimal data prep necessary because, as mentioned earlier in the presentation, you have a collaborative digital thread where all stakeholders can access the same data. So going into a design review is not time-consuming or stressing, and it uses current data. So here you're able to review multiple variants, multiple different shapes or variants for a scene, multiple environments, color and trim options, different parts and configurations, specific views for reviews, and if desired, different part position variants, such as doors or hood opening and closings. And if you have access to kinematics, these can be implemented as well. And these behaviors can be set with triggers by mouse click, hotkey, or in VR by the selection from your wand. If you want to learn more about this, go to the CATIA Creative Design community, where you will find recorded webinars. And we highly encourage you to join the XGen user community. Start by going to 3ds.com, and from there go to the support tab, then ask your community, and navigating your way through. It's packed with information, including tutorials, training, data samples, demonstrations, and so much more. And best of all, it's completely free. So to wrap it up, you saw a collaborative digital thread in the 3D Experience platform where all stakeholders can access the same data, the creation of simple to complex shapes and patterns intuitively, interactive, and 3D-centric, allowing exploration of styling ideas natively during the design process, and it's flexible. The spirit of XGen is to be available anytime, anywhere, and on any device, because everything is computed on a server which means you can work from whatever computer you want at any given point of your work in progress.